Far beyond Neptune's orbit, in the cold void where sunlight becomes only a distant point against the cosmic darkness, 5 mechanical pioneers continue in an extraordinary, unknown way. Decades ago, from our blue planet, these spacecraft now roam regions that nothing created by humanity has ever explored before. They drift through interstellar space, and each carries messages designed for alien eyes that may never look at them millions of years from now. What these robotic explorers have discovered questions everything scientists once believed about our cosmic neighborhood. From moons harboring hidden oceans to storms larger than Earth, from magnetic mysteries at the edge of the solar system to deep loneliness captured in a single photograph, these missions have redesigned our understanding of the universe. If you have subscribed, we can begin the journey. Among these travelers, Voyager 1 stands as humanity's most distant messenger. Having traveled more than 14 billion miles, this washing machine-sized probe crossed an invisible threshold in August 2012 that no human-made object had ever crossed before. The heliosphere, that immense bubble of solar wind that protects everything inside our solar system, finally surrendered to interstellar space. Scientists had theorized about this boundary for generations, imagining it as a simple line separating the domain of our sun from beyond the galaxy. Reality turned out to be far more complex and astonishing. Imagine our solar system as an island of warmth and protection floating in a vast, cold ocean. The sun constantly emits charged particles flowing in all directions and forms this protective sphere extending far beyond Pluto's orbit. For 35 years, Voyager 1 traveled within this familiar region. Then suddenly, the instruments detected a dramatic change. Solar particles dropped to 1/1000th of their previous levels, while ancient radiation coming from distant exploded stars increased dramatically. The probe had entered a realm governed by forces coming from all across the galaxy. What made this transition extraordinary was how scientists confirmed it. When violent eruptions on the sun sent shockwaves racing outward through space, these disturbances eventually reached Voyager 1. The waves caused electrons in the surrounding plasma to vibrate at specific frequencies and created a cosmic symphony that revealed the density of space around the spacecraft. The music of space itself announced that Voyager had crossed into the interstellar region. This was not a smooth transition, like moving from one room to another. Instead, it was like entering a turbulent region where a river's current meets ocean waves. Solar wind particles were colliding chaotically with interstellar matter across millions of miles. Today, this mechanical explorer continues to move away from the sun at a speed of 38,000 miles per hour. With every passing second, it penetrates 11 miles deeper into alien territory. Radio communications now take more than 22 hours to cross the distance between Voyager and Earth, and this delay continues to grow. The spacecraft's nuclear power source is slowly decaying and may allow another 10 years of operation before eternal silence. Yet, its journey into the unknown has only just begun, and what lies ahead will challenge our assumptions even further. The first major surprise came immediately after crossing into interstellar space. Every computer model predicted that this region would be nearly empty, a cosmic void with perhaps one particle drifting through each cubic centimeter of space. Our sun creates a hot plasma bubble, pushing against this so-called emptiness, so logic suggested that beyond the boundary, Voyager would encounter even thinner, colder matter stretching between distant stars. Instead, the measurements showed that space was actually denser than the region it had just left behind. This discovery forced a complete rethinking of how our solar system interacts with its galactic environment. Imagine stepping out of a crowded subway car, expecting to find an empty platform, only to discover that the platform is even more crowded. Voyager 1 experienced something similar when the plasma density increased dramatically as it crossed the heliopause. This finding meant that the galaxy contains far more matter between the stars than anyone had realized. This matter affects star formation, planetary development, and the evolution of entire solar systems on cosmic timescales. Interstellar space is not empty at all, but filled with a thin soup of gas and dust that our sun must pass through as it orbits around the galactic center. This dense interstellar plasma also carries twisted magnetic fields shaped by forces operating on scales larger than entire star systems. These magnetic highways guide cosmic rays and high-energy particles across vast distances and form an invisible network connecting different regions of the galaxy. Understanding these structures helps explain how radiation from ancient supernovae reaches Earth and how it affects everything from satellite operations to atmospheric chemistry. Our protective bubble constantly battles these external forces and maintains a delicate balance between the power of our star and the pressure of the galaxy. As Voyager 1 entered interstellar space, its earlier encounters with Jupiter and Saturn had already revolutionized planetary science. In March 1979, when the probe's cameras captured images of Jupiter's moon Io for the first time, mission controllers initially suspected an instrument malfunction. The transmitted images showed a world painted in vivid yellows, oranges, and reds, with massive volcanic plumes blasting hundreds of miles into space. Scientists were expecting another cold, cratered moon similar to Earth's moon. Instead, they discovered the most volcanically active body in the entire solar system, a moon experiencing a geological fury that makes terrestrial volcanism seem mild by comparison. Io hosts more than 400 active volcanoes, and some of them hurl sulfur and molten rock up to 300 miles high. If these eruptions occurred on Earth, they would stretch from New York to Boston. Sulfur compounds create alien landscapes in hues seen nowhere else in the universe. So what powers this volcanic hell on a moon smaller than Earth, orbiting 5 times farther from the Sun than Earth? The answer lies in gravitational torture. Jupiter's immense gravity constantly squeezes and stretches Io as the moon follows its elliptical orbit. Like bending a paperclip back and forth until it heats up, this gravitational kneading turns Io's interior into a churning ocean of molten rock. Making matters worse, Io is trapped in a gravitational tug-of-war with Jupiter's other large moons, Europa and Ganymede. Every time Io completes one orbit, Europa completes exactly half, while Ganymede completes 1/4. This perfect mathematical relationship, known as orbital resonance, prevents Io from settling into a circular orbit, where it could cool and find peace. Volcanic activity pumps out 2 tons of material every second, constantly resurfacing the moon and erasing any impact craters. The sulfur blasted from these geysers escapes into space due to Io's weak gravity, forming a vast ring around Jupiter, invisible to Earth-based telescopes. Even stranger, Io's volcanoes create their own weather systems. Sulfur dioxide gas released from eruptions condenses into frost during the moon's short night, then sublimates back into the atmosphere at sunrise, creating daily snowfall made of sulfur compounds. These alien weather systems operate under physics unknown on Earth, where volcanic activity and atmospheric processes merge in unique ways. The discovery of Io's volcanic nature proved that moons can be geologically active worlds rather than dead rocks, and fundamentally changed how we think about planetary moons throughout the universe. Jupiter held additional surprises. On March 5, 1979, mission planners hoped to detect lightning in the planet's atmosphere by taking a long-exposure photograph of Jupiter's dark side. Instead, they found a delicate band of light encircling the giant planet like a cosmic wedding ring. For more than 3 centuries, astronomers studying Jupiter through telescopes had completely missed this ring system because it was simply too faint and too close to Jupiter's bright disk. This discovery revealed that ring systems are not unique to Saturn, but represent a fundamental process wherever large planets capture small moons. Jupiter's rings operate on principles completely different from Saturn's famous icy rings. While Saturn's rings shine brightly with reflective water ice, Jupiter's rings are made of microscopic dust particles, darker than coal. These tiny grains absorb most of the sunlight that strikes them, making the rings nearly invisible unless viewed at the perfect angle with the sun behind them. The dust comes from Jupiter's innermost moons, which are constantly blasted by micrometeoroids traveling at tens of thousands of miles per hour. Each impact knocks dust particles loose from these small moons, and electromagnetic forces cause these particles to spiral inward toward Jupiter. The ring particles organize themselves into distinct structures: a main ring, a gossamer ring, and a faint halo, each one controlled by different physical forces. This organization showed that ring systems represent dynamic, evolving structures rather than static decorations. The rings interact with Jupiter's powerful magnetosphere in ways that create their own auroral displays. Charged particles from Jupiter's radiation belts strike the ring particles, causing them to glow faintly. The entire ring system renews itself every few thousand years, making it relatively young and dynamic compared to Saturn's ancient, stable rings. Voyager also detected radio signals from Jupiter that solved a long-standing mystery. Strange whistling sounds were coming from the planet's night side, the characteristic signature of lightning discharges powerful enough to be heard across millions of miles of space. These were not ordinary lightning strikes. Individual storms covered areas larger than entire continents, and single strikes released more energy than all of Earth's power plants combined. Like a cosmic radar, by tracking these radio signals, Voyager turned its cameras toward Jupiter's dark hemisphere and captured the first images of alien lightning, bright flashes illuminating cloud tops from below. These Jovian storms operate on a scale that dwarfs terrestrial weather. Individual storm systems can last for months or even years and grow large enough to swallow multiple Earth-sized planets. Jupiter's most famous storm, the Great Red Spot, has raged furiously for at least 3 centuries, with winds along its edges reaching 400 miles per hour, twice as fast as the strongest hurricanes ever recorded on Earth. What makes Jupiter's lightning especially striking is its location. On Earth, lightning forms in water clouds where ice crystals collide and build up electric charges. Jupiter's lightning occurs in clouds made of ammonia ice crystals, floating in an atmosphere composed mostly of hydrogen and helium. Temperature differences drive this alien weather system. Jupiter's core burns at 24,000 degrees Fahrenheit, hotter than the surface of the Sun, while the cloud tops freeze at 200 degrees below zero. This creates enormous convection currents that carry heat from the interior into space and produce updrafts and downdrafts that make Earth's most violent hurricanes seem gentle. Remarkably, Jupiter generates more heat than it receives from the Sun, producing internally twice as much energy as solar heating provides. This internal heat source drives weather patterns that have continued for centuries without seasonal change. Beneath the frozen surfaces of seemingly dead moons, Voyager's cameras revealed the first hints of vast oceans that could harbor alien life. Jupiter's 4th largest moon, Europa, appeared as a billiard ball smooth world covered by a network of dark cracks crossing bright icy plains. The complete absence of impact craters indicated that Europa's surface was geologically young. Despite orbiting far from the sun's warmth, it was somehow renewing itself. The dark lines etched across the surface resembled frozen rivers or the patterns formed when thin ice fractures in Earth's Arctic seas. Similarly, when Voyager 2 photographed Saturn's small moon Enceladus in 1981, it revealed a world divided between ancient, heavily cratered terrain and smooth, craterless regions gleaming like fresh snow. The contrast was so striking that it looked as if two different moons had been fused together. These mysterious surfaces revolutionized our understanding of where life might exist in the solar system. Both moons experience the same tidal heating that tortures Io, but at a gentler level. Their elliptical orbits create gravitational flexing that does not produce violent volcanism, but generates enough heat to melt ice into liquid water, a subtle warming that preserves oceans beneath protective ice shells. Think of these moons as cosmic thermos bottles. Ice shells 10 to 15 miles thick insulate the liquid water below from the cold vacuum of space, where temperatures plunge to 300 degrees below zero. Meanwhile, tidal heating from the giant planets prevents the water from freezing solid and preserves vast oceans containing more water than all of Earth's seas combined. Europa's ocean, hidden beneath its icy shell, likely contains twice as much water as all of Earth's oceans. The ice shell behaves like Arctic pack ice, constantly fracturing and refreezing as the liquid ocean below moves and churns. These discoveries fundamentally changed how scientists think about habitability in the solar system. Life on Earth requires liquid water, and for decades, researchers assumed this meant planets had to orbit within a narrow zone around their stars, not too hot, not too cold. But Europa and Enceladus proved that liquid water can exist almost anywhere when heated by gravitational forces rather than starlight. If moons orbiting giant planets can preserve oceans for billions of years, the number of potentially habitable worlds in our galaxy could be thousands of times greater than anyone ever imagined. When Voyager 2 approached Neptune in August 1989, it discovered the most violent winds in the entire solar system. A world that should have been frozen into stillness was screaming. Neptune orbits 30 times farther from the Sun than Earth and receives only 1,000th as much solar energy. At this distance, the Sun appears as little more than a bright star. Logic suggested that Neptune should be a quiet, cold world with almost no atmospheric activity. Instead, instruments detected wind speeds reaching 1,500 miles per hour, nearly twice the speed of sound, fast enough to circle Earth's equator in less than 17 hours. These supersonic rivers of gas make Earth's most destructive hurricanes seem like summer breezes. The fastest winds ever recorded on Earth peaked at just over 300 miles per hour during extreme hurricanes. Neptune's atmosphere routinely produces winds 5 times stronger within storm systems larger than our entire planet. What makes Neptune's winds even more mysterious is their direction. On Earth, the Sun heats the tropics more than the polar regions, creating temperature differences that drive weather patterns. Neptune receives sunlight so weak that temperature differences between the equator and the poles reach only a few degrees. Yet this minimal energy input drives atmospheric circulation more violent than anything else in our solar system. The answer lies in Neptune's internal heat engine. Like Jupiter, Neptune produces more energy than it receives from the Sun and generates internally 2.5 times more heat than solar heating alone provides. The planet's core burns at temperatures of approximately 4,000 degrees Fahrenheit, creating powerful convection currents that rise through thousands of miles of hydrogen and helium atmosphere. Neptune's winds blow backward against the planet's rotation, like rivers flowing uphill. Most planets rotate faster at the equator than at the poles due to centrifugal force, and their strongest winds typically blow in the same direction as rotation. Neptune's winds do the exact opposite. Voyager 2 discovered massive storm systems churning through Neptune's atmosphere, among them the Great Dark Spot, an anticyclonic storm comparable in size to Jupiter's Great Red Spot. Unlike Jupiter's centuries-long storms, Neptune's weather changes rapidly. The Great Dark Spot observed by Voyager had completely vanished when the Hubble Space Telescope studied Neptune just a few years later. The combination of intense internal heating and minimal solar input creates a unique atmospheric laboratory where traditional weather models completely break down. Neptune essentially runs its own weather system and converts heat from its interior into kinetic energy that drives winds faster than most spacecraft travel. Voyager 1's cameras revealed Saturn's rings in unprecedented detail and discovered something that changed our understanding of how cosmic debris organizes itself: small moons acting like gravitational traffic police. Saturn's ring system spans more than 175,000 miles from edge to edge, yet in most places measures less than 30 feet thick, proportionally thinner than a sheet of paper. Scientists had assumed these rings were formed by random collisions and gravitational forces producing relatively smooth, uniform structures. Instead, Voyager found rings containing sharp edges, gaps, strands, braids, and structures that appear to defy basic orbital mechanics. The biggest surprise was the F-ring, a narrow band of particles orbiting just beyond Saturn's main ring system. This ring looked braided like hair, with strands weaving inward and outward in complex patterns that should have been impossible. Gravitational forces should smooth out such structures within a few orbital periods. Yet the F-ring retained its intricate braided appearance, like a cosmic rope frozen in space. The solution came when Voyager discovered two small moons, Prometheus and Pandora, orbiting on either side of the F-ring. These shepherd moons use their gravity to keep the ring particles confined within a narrow band, preventing them from spreading outward or spiraling inward toward Saturn. Think of these shepherd moons like cosmic cowboys herding a cattle drive. Any ring particle that strays from the main herd is nudged back into line by the gravitational influence of one of the shepherds. This process happens continuously, and because the shepherd's orbital periods differ slightly from those of the ring particles, their repeated passing creates the braided structures. The discovery of shepherd moons revolutionized our understanding of ring dynamics throughout the solar system. Similar gravitational shepherding creates gaps in Saturn's rings, maintains the sharp edges of Uranus's rings, and influences planetary ring systems around distant gas giants. By the late 1990s, careful tracking of the Pioneer spacecraft revealed that they were falling behind their predicted positions by about 2 miles per year, a small discrepancy that grew larger with each passing year. The spacecraft were slowing down, as if an invisible force were gently but continuously pulling them back toward the sun. This became known as the Pioneer anomaly, and it threatened to undermine our understanding of gravity. The mystery deepened because no known force could explain the slowdown. The spacecraft were far beyond the gravitational influence of any planet. Solar radiation pressure should have pushed them away from the sun, not slowed them down. Scientists proposed increasingly exotic explanations. Perhaps gravity behaved differently at the edge of the solar system. Perhaps dark matter, the mysterious substance thought to make up most of the universe, was concentrated in our region of space and was creating drag on the spacecraft. Some theorists suggested that the pioneers were encountering a new fundamental force of nature, or were being influenced by extra dimensions predicted by advanced theories of physics. The implications were startling. If gravity did not behave as expected over large distances, it could explain why galaxies rotate faster than they should, and why the expansion of the universe appears to be accelerating. The mystery lasted for more than 30 years, produced hundreds of scientific papers, and inspired entire conferences. The breakthrough came when researchers realized they needed to account for the heat radiation coming from the spacecraft themselves. Both pioneers carried nuclear power sources that generated electricity by converting radioactive decay into heat. That heat had to go somewhere, and even tiny imbalances in how that heat was radiated into space could create thrust, like holding a flashlight in space and being pushed backward by the light it emits. Detailed thermal modeling showed that the pioneers' anomalous slowdown matched perfectly with a recoil force created by heat being radiated unevenly from their nuclear power sources and internal electronics. New Horizons shattered every expectation about Pluto, revealing not a cold, dead rock, but a world more geologically active than Earth's moon. In July 2015, the first detailed images from New Horizons showed a heart-shaped region on Pluto's surface that immediately captured global attention. This feature is roughly 900 miles across, approximately the distance from New York to Atlanta. But this was not just a beautiful pattern. The heart represented something scientists thought was impossible: active geology on a dwarf planet smaller than Earth's moon, orbiting 39 times farther from the Sun. The western lobe of Pluto's heart consists of a vast plain of frozen nitrogen completely free of impact craters, despite having been exposed to 4.5 billion years of cosmic bombardment. On a dead world, craters should accumulate like scars on old skin. Their absence meant that something was continuously renewing Pluto's surface, erasing the evidence of meteor impacts. New Horizons revealed the mechanism: convection cells in the nitrogen ice sheet operating like a cosmic lava lamp. Radioactive decay in Pluto's rocky core produces enough heat to keep the base of the nitrogen ice sheet slightly warmer than the surface. And as warmer nitrogen rises and colder nitrogen sinks, enormous convection cells are created. Each convection cell is roughly 12 miles across and takes about 500,000 years to complete a cycle. Incredibly slow by Earth standards, but remarkably fast for such a distant and cold world. The process creates a polygonal pattern visible in the images, resembling frozen honeycombs spread across an area larger than Texas. But Pluto's geological surprises did not end with nitrogen glaciers. The spacecraft discovered mountain ranges made of water ice, rising more than 11,000 feet above the surrounding plains, higher than Mount Hood in Oregon. At Pluto's frigid temperatures, water ice becomes as hard as granite and can support mountain ranges for billions of years. Even more striking, New Horizons found evidence of recent volcanic activity on Pluto. Not eruptions of molten rock, but cryovolcanoes spewing mixtures of liquid nitrogen, water, and ammonia. These ice volcanoes create smooth, young surfaces that show the dwarf planet has remained geologically active within the last few million years, possibly continuing to the present day. Perhaps most astonishing of all, New Horizons discovered that beneath Pluto's frozen surface, there may be a subsurface ocean of liquid water. Gravitational interactions between Pluto and its large moon Charon, combined with radioactive heating, could preserve pockets of liquid water for billions of years, increasing the dizzying possibility that even worlds on the frozen edge of the solar system can retain the basic ingredients necessary for life. On February 14, 1990, Voyager 1 turned its cameras back toward home and captured an image that changed how humanity sees itself in the universe. The photograph showed Earth as a small blue dot suspended in a sunbeam, occupying less than a pixel in the vast dark space. From Voyager's position more than 4 billion miles away, our entire world appeared smaller than a grain of sand seen across a football field. Every human being who ever lived, every civilization that rose and fell, every war fought, and every peace treaty signed, all existed on that barely visible point of light. This image, later called the pale blue dot, represented the most distant photograph of Earth ever taken at the time. Voyager 1 had traveled farther than any human creation before it, reaching a distance where Earth no longer dominated the sky, but instead became just another point of light among countless others scattered in the cosmic darkness. The photograph was almost never taken. NASA engineers worried about turning Voyager's cameras back toward the sun and feared that intense solar radiation could damage the instruments. But Carl Sagan, who championed messages to alien civilizations on both Voyagers, convinced NASA to attempt the Solar System family portrait. Among all the worlds visible in these images, only Earth showed the distinctive blue color, marking it as a planet with liquid water, oceans, and an oxygen-rich atmosphere. The pale blue dot occupied just 0.12 pixels in the image, a speck of cosmic dust caught in a scattered sunbeam. No continents, no clouds, no sign of the living life that makes Earth unique in the known universe. From Voyager's perspective, our world appeared completely insignificant, indistinguishable from the countless other points of light scattered across the galaxy. And yet, this tiny dot contained everything humans have ever known or cared about. Every person who ever lived their hopes and dreams, every species that evolved over billions of years. The photograph served as a profound reminder of Earth's fragility and isolation. There was no other refuge for human civilization, no backup planet waiting in our solar system. The nearest potentially habitable worlds orbit other stars trillions of miles away, completely unreachable with current technology. For the foreseeable future, that pale blue dot represents the only home humanity will ever know. From the edge of the solar system, all human conflicts and territorial disputes seemed trivial and meaningless compared to the vast emptiness surrounding our small world. Pioneer 10 became the first spacecraft to attempt passage through the asteroid belt in 1972, and no one knew whether it would survive. Science fiction films portrayed asteroid belts as chaotic minefields, with spacecraft dodging house-sized rocks as they passed through fields of cosmic debris. Scientists worried that Pioneer 10 could be beaten to death by high-speed impacts. Some estimates suggested the odds of a safe passage were only 50-50. The asteroid belt stretches roughly 175 million miles and contains millions of rocky fragments ranging from pebbles to objects hundreds of miles across, racing through space at speeds up to 45,000 miles per hour. However, when Pioneer 10 entered the belt on February 15, 1973, it discovered something completely unexpected. The asteroid belt was mostly empty space. Despite containing millions of individual objects, the belt was so sparse that Pioneer encountered almost no debris during its passage. The total mass of all the asteroids is less than 5% of Earth's moon, spread across a volume of space larger than Mars's orbit. Think of the asteroid belt like a massive parking lot the size of Texas with only a few dozen cars randomly scattered. From any point, you could look in every direction and see empty space stretching to the horizon. This discovery revolutionized mission planning for future spacecraft. If Pioneer could safely pass through the asteroid belt, then Voyager, Galileo, Cassini, and dozens of other probes bound for the outer planets could pass as well. The belt was not an obstacle to exploration, but a cosmic superhighway linking the inner and outer solar system. The emptiness also revealed important clues about the formation of our solar system. The asteroids represent leftover building blocks from planet formation 4.5 billion years ago, material that never coalesced into a full-sized planet due to gravitational disruption from nearby Jupiter. Bolted to the antenna supports of Pioneer 10 and Pioneer 11, two gold plaques 6 inches by 9 inches carry humanity's first message designed for alien eyes. The idea came from Carl Sagan after realizing that both Pioneers would eventually drift into interstellar space and could potentially outlive human civilization itself. If alien explorers were to find these ancient probes millions of years in the future, they would discover humanity's first attempt at saying hello to the cosmos, a message in a bottle cast into the vast ocean between the stars. The plaques feature line drawings of a naked human man and woman standing in front of an outline of the Pioneer spacecraft for scale reference. The man's hand is raised in a gesture of goodwill, but the designers worried that aliens might interpret any gesture as threatening or meaningless. To avoid depicting temporary fashion choices that could confuse extraterrestrial archaeologists trying to understand human biology, they chose to show the humans without clothing. But the real genius lies in the scientific information engraved beside the human figures. The plaques include a map showing Earth's location relative to 14 pulsars, rotating neutron stars that emit regular radio beams like cosmic lighthouses. Because pulsars slow down at predictable rates over millions of years, aliens could use this information to determine both where the spacecraft came from and when it was launched. Think of the pulsar map as a cosmic GPS system, readable by any scientifically advanced civilization. Lines radiating from Earth point to different pulsars with symbols indicating each pulsar's rotation rate and distance. Even if human civilization were to disappear, these cosmic beacons would continue to broadcast their regular signals for millions of years, providing permanent navigation markers that aliens could use to find Earth. The gold-plated aluminum plaques were designed to survive for millions of years in the harsh environment of interstellar space. The gold coating protects the engraved aluminum from corrosion caused by cosmic rays and interstellar dust. Both Pioneers carry identical plaques, doubling the chances that humanity's first interstellar message will eventually be found. Pioneer 10 is heading toward the constellation Taurus and will pass near the star Aldebaran in about 2 million years. Pioneer 11 is traveling toward Aquila and will encounter nearby stars in approximately 4 million years. On New Year's Day 2019, New Horizons flew past the oldest and most pristine object ever studied by humans, a frozen relic left over from the birth of the solar system. Arrokoth orbits in the Kuiper Belt, more than 4 billion miles from the Sun. At this immense distance, the object has remained almost unchanged since the solar system formed 4.5 billion years ago. Unlike planets and moons that were heated, melted, and reshaped by geological processes, Arrokoth preserves the original materials and structure of the primordial disk from which all worlds formed. The spacecraft revealed an object never seen before: 2 lobes about 21 miles long, connected by a narrow neck resembling a cosmic snowman or a spinning dumbbell. The unusual shape immediately told scientists that Arrokoth formed through a gentle process rather than violent collisions. The 2 lobes formed as separate objects that slowly spiraled together and merged at walking speed, producing not enough heat to melt or significantly alter their internal structures. This discovery revolutionized our understanding of how planets form. Traditional theories suggested that planetary building blocks grew through high-speed collisions that gradually built up larger objects. Arrokoth's pristine condition and gentle binary structure proved that at least some building blocks formed through gravitational instabilities in the early solar nebula, a much calmer process that preserved primordial materials in their original state. Images showed that Arrokoth's surface is covered with small hills and pits, but is completely lacking the large impact craters that scar most solar system objects. The absence of large craters confirmed that the Kuiper Belt is a relatively quiet neighborhood where ancient objects can survive unchanged for billions of years. New Horizons is approaching the first of several invisible barriers that mark the edge of our Sun's protective domain, a cosmic battlefield where solar particles collide with the interstellar medium. The termination shock represents one of the most dramatic boundaries in the solar system, yet it remains completely invisible to human eyes. Here, the solar wind, that steady stream of particles blasting outward from the Sun at over 1 million miles per hour, suddenly slams into interstellar matter and drops to subsonic speeds. The collision creates a shock wave stretching across billions of miles and forms a vast spherical front advancing ahead of our entire solar system as it moves through the galaxy.
Imagine our solar system as a speedboat racing across a lake. As the boat moves forward, it pushes water aside, creating a wake and a bow wave. The termination shock is like that bow wave, but instead of water, it is made of colliding streams of charged particles heated to temperatures of millions of degrees. The shock region stretches for hundreds of millions of miles and creates some of the most extreme plasma conditions found anywhere in nature. New Horizons will likely encounter this boundary in the late 2020s and will become only the third spacecraft after Voyager 1 and 2 to cross the termination shock.
New Horizons detected more cosmic dust impacts than any computer model had predicted, suggesting that our solar system contains far more debris than previously imagined. The spacecraft carries a student-built dust counter that measures particles smaller than grains of sand as they strike its detectors at speeds reaching 45,000 miles per hour. Each impact creates a small flash of light and a voltage pulse that reveals the particle's mass and speed. Scientists expected dust impacts to steadily decrease as New Horizons moved farther from the Sun. Instead, the dust counter recorded consistently high impact rates, even as the spacecraft traveled deeper into the Kuiper Belt. Ground-based observing telescopes had detected fewer large objects visible at greater distances and suggested that the Kuiper Belt ended rather abruptly. However, the New Horizons measurements told a different story. The impact rate stubbornly remained high, indicating that microscopic debris continued far beyond the region where large Kuiper Belt objects became sparse. Either our understanding of the Kuiper Belt structure was completely wrong, or New Horizons was detecting evidence of a previously unknown population of objects. The discovery suggests that the Kuiper Belt may extend much farther than previously thought, likely containing a second, more distant belt of debris left over from the formation of the solar system. When Voyager 1 crossed into interstellar space, it detected something impossible. The Sun's magnetic field refused to reverse direction as every computer model had predicted. For decades, scientists had assumed that crossing the heliopause would be like passing through a magnetic membrane separating two distinct regions. On the solar system side, magnetic field lines should point in directions determined by the Sun's rotation and activity. On the interstellar side, they should follow completely different orientations set by galactic processes operating on much larger scales. The boundary between these two magnetic fields should have been clear, like moving from a region where all compass needles point north into one where they suddenly point south. Instead, Voyager found magnetic chaos that contradicted every theoretical prediction. The field strength changed dramatically as expected, but the direction stubbornly remained similar to what the probe measured while still inside the heliosphere. The magnetic field appeared to have developed a kind of cosmic amnesia. It had forgotten that it was supposed to reverse direction when entering interstellar space. This discovery suggested that the boundary between the Sun and interstellar space is far more complex than a simple dividing line between two magnetic regions. Rather than a sharp transition, Voyager encountered a turbulent mixing zone where solar and galactic magnetic fields intertwine like twisted cables. In the vast emptiness between the stars, our most distant spacecraft encounter extreme cold approaching the theoretical limit where all atomic motion comes to a permanent halt. The temperature of interstellar space averages about 4 degrees above absolute zero, which is minus 455 degrees Fahrenheit, colder than anything that naturally occurs on Earth. At these temperatures, the few atoms scattered through space move so slowly that it is difficult to meaningfully describe them as matter at all. If you could somehow carry a cup of water into interstellar space, it would freeze solid in microseconds and then continue cooling until the ice became harder than steel. Voyager 1's instruments measured this cosmic deep freeze as the spacecraft passed from the relatively warm environment of our solar system's heliosphere into the cold interstellar medium. The temperature difference appears small in absolute terms, only a few degrees, but it represents crossing a fundamental threshold where the physics of matter begins to behave in strange ways. Think of interstellar space as nature's ultimate refrigerator. The universe has been cooling for more than 13 billion years since it began expanding after the Big Bang. The only sources of heat in this cosmic freezer are the faint radiation left over from creation and the occasional energy released when sparse interstellar atoms collide with one another at incredibly slow speeds. Extreme cold affects how our spacecraft operate in ways their designers did not fully anticipate. Electronic circuits that work perfectly at room temperature, or even in the cold vacuum near Earth, begin to behave unpredictably as they approach these cosmic temperature extremes. Metal components contract and become brittle. Lubricants in moving parts freeze into solid blocks. Most striking of all, the cold of interstellar space actually helps preserve our distant spacecraft far longer than anyone expected. Chemical reactions that cause corrosion and degradation slow to nearly imperceptible rates at these temperatures. Materials that would rapidly decompose on Earth can remain potentially intact for millions of years in the cosmic deep freeze. Among humanity's interstellar emissaries, Voyager 2 alone follows a path that carries it below the plane of the solar system, revealing a completely different view of our cosmic neighborhood. After completing its grand tour of the outer planets, Voyager 2's 1989 encounter with Neptune sent the spacecraft plunging southward at a steep angle relative to the disk in which the planets orbit. This trajectory makes Voyager 2 unique among the 5 spacecraft leaving our solar system. All the others travel in roughly the same flat plane that includes Earth, Mars, Jupiter, and the other planets. Imagine the solar system as a giant dinner plate with the sun at the center and all the planets arranged around the edge. Most of our interstellar spacecraft skim across the surface of this plate as they head into deep space. But Voyager 2 dives beneath the plate, providing humanity's only view of what lies below the familiar plane of our solar system. This southern trajectory revealed that the heliosphere has a distinctly misshapen form rather than the perfect sphere scientists expected. Voyager 2 crossed into interstellar space at a different distance than Voyager 1, confirming that the boundary between the Sun and interstellar space changes dramatically depending on direction. Beyond the heliosphere's protective boundary, our spacecraft face a more hostile radiation environment than anything encountered in Earth orbit. A constant bombardment of high-energy particles from exploding stars scattered across the galaxy. Galactic cosmic rays represent some of the most energetic events in the universe. These particles race through interstellar space at nearly the speed of light and carry millions of times more energy than anything produced in Earth's most powerful particle accelerators. A single cosmic ray proton can pack as much energy as a baseball thrown by a bat, concentrated into an area smaller than an atomic nucleus. When Voyager 1's instruments crossed into interstellar space, they detected a 9% increase in cosmic ray intensity and confirmed that our sun's heliosphere provides significant protection from galactic radiation. Inside the solar system's magnetic bubble, the solar wind creates a partial barrier that deflects many cosmic rays before they can reach the inner planets. Outside this protection, spacecraft face the full fury of radiation from stellar explosions that occurred millions of years ago. These cosmic rays originated in some of the most violent events in the galaxy: supernovae, places where massive stars explode with the power of billions of hydrogen bombs detonating every second for months at a time. The magnetic shield that protects all life in our solar system from deadly galactic radiation is slowly weakening as our sun ages and its influence over interstellar space begins to diminish.
Our sun creates the heliosphere by continuously blasting charged particles into space at speeds exceeding 1 million miles per hour. This solar wind inflates a vast magnetic bubble around our entire solar system, extending far beyond Pluto's orbit and pushing back against the hostile radiation environment of interstellar space. Without this protection, Earth would be bombarded by cosmic rays intense enough to strip away our atmosphere and sterilize the planet's surface.
Every day, radio signals carrying humanity's most distant conversations travel for more than 22 hours through the emptiness between the stars and maintain our fragile connection with the spacecraft that have become the loneliest objects humans have ever built. Signals from Voyager 1, now more than 14 billion miles away, reach Earth's radio telescopes as whispers barely distinguishable from the cosmic background noise. The spacecraft's radio transmitter produces only 23 watts of power, less than a typical light bulb, and this faint signal must cross distances that light itself takes nearly a full day to traverse. When Voyager's radio waves reach Earth, they have spread across such immense distances that the total power collected by our largest antennas is about 1/billionth of the energy required to light a birthday candle. These signals are so weak that they could be completely overwhelmed by a cell phone transmission sent from the same distance. And yet, NASA's Deep Space Network can still decode the spacecraft's messages with remarkable clarity. The network consists of 3 large antenna complexes strategically located around the Earth in California, Spain, and Australia. As our planet turns, at least one of these facilities is always maintaining communication with our interstellar explorers. Deep within the heart of every interstellar spacecraft, radioactive plutonium slowly transforms into other elements, producing the heat that powers humanity's most distant outposts while simultaneously counting down to their inevitable silence. The radioisotope thermoelectric generators aboard our interstellar explorers contain no moving parts, fuel tanks, or solar panels that could fail or be damaged during decades of travel. Instead, they rely on the steady decay of plutonium-238 atoms, which naturally transform into uranium over timescales measured in human generations. Each radioactive decay releases a tiny burst of heat, and billions of these microscopic furnaces together produce enough energy to keep the spacecraft alive. When Voyager 1 was launched in 1977, its nuclear power system produced approximately 470 watts, enough to run a small microwave oven. Today, nearly 5 decades later, as the plutonium fuel transforms into non-radioactive elements, that power output has dropped to roughly 250 watts. The spacecraft loses about 4 watts of power each year, a gradual dimming that cannot be stopped or reversed. Think of these power systems as cosmic candles burning in the interstellar dark. They were lit with enough fuel to burn brightly for decades, but the flame grows dimmer with each passing year and eventually flickers out. The 2 golden records attached to Voyager 1 and Voyager 2 contain the most sophisticated star maps humanity has ever created. Cosmic GPS coordinates that will remain accurate for millions of years after human civilization is forgotten. The Voyager Golden Records represent humanity's upgrade from the simple pioneer plaques, containing not only images and symbols, but also real sounds and music from Earth. Each 12-inch gold-plated copper disc holds 90 minutes of audio, spoken greetings in 55 languages, natural sounds like thunder and birdsong, and musical selections ranging from Bach to Chuck Berry to traditional folk songs from around the world. The most ingenious feature of the recording is its cover design, which functions as a cosmic Rosetta Stone that any scientifically advanced civilization could decipher. The cover contains a more sophisticated pulsar map than those on the Pioneer plaques, a star chart showing Earth's position relative to 14 pulsars scattered across our region of the galaxy.
Pulsars are among the most precise timekeepers in the universe. These rapidly rotating neutron stars emit radio beams that sweep through space like lighthouse beams, creating perfectly regular pulses detectable from thousands of light years away. Each pulsar has its own unique pulse rate, and these rates slow at predictable intervals as neutron stars gradually lose their rotational energy. Across the cosmic darkness, 5 human-made objects are following different paths that will carry them to different regions of the galaxy and spread humanity's presence across a volume of space larger than all stellar empires combined. Pioneer 10, leading our interstellar fleet, is heading toward the constellation Taurus and racing toward an encounter with the red giant star Aldebaran in roughly 2 million years. By then, the spacecraft will have traveled 68 light-years from home, farther than most of the stars visible in Earth's night sky. Pioneer 11 follows a different trajectory toward the constellation Aquila for a much closer encounter with a nearby star in about 4 million years. Humanity's most distant envoy, Voyager 1, is racing toward the constellation Ophiuchus at a speed of 38,000 miles per hour. In approximately 40,000 years, it will pass within about 1.5 light-years of a star. Although this sounds like a close encounter, it is actually about 60,000 times farther than the distance at which Earth orbits our Sun, close only by interstellar standards. Voyager 2 follows its unique southern trajectory toward a completely different region of space. Thus, the 2 Voyagers will become humanity's first envoys to entirely different stellar neighborhoods, doubling our chances of contact with alien civilizations. Think of these 5 spacecraft as humanity's first attempt at galactic colonization. They carry no humans or even life, but they spread our ideas, our music, and our scientific knowledge across distances that will never be crossed by human passengers. They represent the seeds of human consciousness scattered into the cosmic wind, hoping to take root in alien minds millions of years in the future. The scale of their different journeys defies human comprehension. By the time any one of these spacecraft approaches another star, our Sun will have completed multiple orbits around the center of the galaxy. Entire populations of stars will have been born, lived, and died. Ice ages will have come and gone on Earth. Human civilization, if it survives, will be as different from humanity today as we are from the first bacteria that crawled from the primordial seas. Yet these 5 small emissaries will continue their patient journeys, carrying the hopes and dreams of a species that dared to reach beyond its planetary cradle. They carry messages designed to outlive the civilizations that created them, golden records and plaques that will remain readable long after the last human is forgotten. In an unimaginable future, when our Sun exhausts its nuclear fuel and Earth becomes a frozen wasteland, these spacecraft will still be racing across the galaxy. They will serve as monuments to human curiosity and creativity, proof that intelligence once arose on a small blue planet orbiting an ordinary star on the outer edges of a typical spiral galaxy. The discoveries made by our most distant probes have transformed our understanding of the cosmos and our place within it. They have revealed that space is not empty, but filled with wonders, that planetary systems are far more complex than anyone once imagined, and that the journey between the stars holds mysteries we are only beginning to understand. As they continue on their endless journeys into eternity, these brave explorers carry the essence of humanity, our insatiable desire to explore, to question, and to reach toward unknown horizons beckoning from the darkness between the stars. It continues with each passing day. In our next videos, we will examine other questions in greater detail. Good night.